Hello and welcome to my channel. My name is Yorgos and this is the AVBoat. If you clicked on this video because you want to find a proper guide on how to set up an NMEA 2K network and also how to set up this little device here, then you are on the right video. So stay tuned. I will be switching now from the camera to the screen, sharing some pictures of how things will be done. And once then we have covered the theory, we will go back to my garage and start installing the network and the analog to digital converter. Let's do it. And let's begin with the basics. What is an NMEA 2000 network? That is a network that is primarily used in marine electronics, and it is a reliable, standardized communication network that connects devices like GPS plotters, autopilots, depth sounders, engines, and fuel sensors, oil pressure sensors, anything that is in the boat that pretty much has some kind of sensor and a cable that can be connected to that network. The benefits of that network are, to begin with, there is the interoperability that it offers, that you can connect devices from different manufacturers, they can connect seamlessly, and they are using a single protocol, so you are reducing any compatibility issues that you might be facing. The wiring is very simplified. It is just a single backbone cable with drop cables that are connecting to each one of the devices. There is data sharing that is happening across multiple devices on a real-time data, so you can get your speed, position, engine stats in one screen. Scalability, you can connect up to 50 devices, so you can easily expand the network as much as you need. And then there is the reliability, that it is designed for harsh marine environments, so it is robust against the water, vibration, electrical noise. It is plug and play, so the devices are easily installed and configured, and they often require minimal setup. And also it offers a power supply, so the network provides the power to the connected devices, hence reducing the need for separate power lines for each device. So it is ideal for modern boating. It offers efficiency, flexibility, and enhanced functionality. Now, let's look more into what is needed in order to build the backbone. And we start with a T-piece. These are quite common in many networks. However, my personal preference is to use a 6-port because it offers more expandability. That then is connected to a cable. That's a normal cable. You can find it in various lengths. They normally come in 2 or 3 meters. However, if you want to connect something shorter, they also have 0.5 meter. And then obviously there is a cable that you need to connect directly to your battery. And as you can see, that already has a fuse already included in that cable. You do not really want to have any kind of oversurge in the network, so that is absolutely necessary to use this fuse. And then finally, and this is a must, the system needs to include 2 terminator resistors. Those are rated at 120 ohms. And if these are not installed, then the network simply will not work. And in here we can see how that backbone would be all of the cables connected. This is the basic NMEA 2K setup, and obviously it has to be connected to the battery. And as mentioned already, please be careful. You need to have that fuse installed. You do not want anything happening. Then in my case, I will be using a Lowrance device as a plotter, depth sounder, using it for the maps. However, I also own a second Lowrance, so in that case, what happens is that the two devices are connected to each other and they can share some data. And that data normally is waypoints and also any let's say fishing spots that you have marked on a map. Those can be shared between the devices. Now, if you happen to own a motor guide electrical anchor, what you can also do is buy this particular GPS waypoint device and connect those to the NMEA network. And what you can achieve with that is that you can use the Lowrance device pointing from the map, and you can tell to the motor guide that you want to be going to a particular spot in the map. So basically the motor guide will drive the boat exactly to the spot that you would want to. And now to the reason why I am creating the NMEA 2000 network on my boat is exactly this device, the CX5003. And that is an analog to digital converter for NMEA network. And as you can see from this particular ad that I found on the internet, what it does is that it's basically picking up different sensors that have analog signal and converts that signal pretty much to a digital format that can be read by the NMEA 2K network. In my particular case, and that might sound a bit funny, is that I want to install a fuel sensor, because one day when I was fishing, I was under the impression that I actually had refueled the boat, and I hadn't. And I was almost left stranded in the middle of the lake. And I was thinking that if only I could get a warning on my plotter, I wouldn't be facing that issue. Hence, then I proceeded with purchasing this particular device. Now, how would that device look in the network? It has the NMEA 2K connection, and one thing that I would want you to be very, very careful is where you see that I have circled. It has the volt signal and the ground. And as I mentioned earlier, normally the NMEA 2K network offers the voltage for powering the devices, but for this particular device, the CX5003, this is not the case. You need to provide the voltage to the device in order for it to work and to be recognized by the network. And as always, please make sure that in the positive end that you connect again a fuse box with a fuse, because in case of an overcurrent, you do not want the device to be destroyed. Now, my outboard motor is quite old and it doesn't have an NMEA 2K interface, so in that respect what I need to do is utilize the already existing analog cables for the RPM signal and the tilt trim signal, and I can then translate them to the NMEA 2K network, and the Lowrance device then will be reading those values. However, you need to be mindful that you cannot be using the gauges and the network at the same time, because the resistance changes, so what the values that will be reported will be completely off. Now, in my case, what is important is to have the fuel gauge sensor so that I can be reading the fuel level in my tank at all times, so that is the most important thing for me. Now, getting a bit more into details, and as we can see from the owner's manual, the operating voltage can be between 9 and 32 volts, so it really doesn't matter if your boat is operating in 12 or 24 volts. But what it is important to notice in here is that by default the sensor's input signal is between 0 and 190 ohms. This is a European standard, so please be mindful that if you are in the US and your input signal is between 240 to 33 ohms, then you need to pretty much ground the switch, as you can see in here, in order to make it operable for the US. Finally, and something that many people get confused, is how to set the RPM speed ratio setting on the CX5003. And in order to find that setting, you need to open the cap for it. And as you can see from the owner's manual, the diesel engine basically has a gear number, and that gear number is the speed ratio. That is fairly easy. Now on the outboard, which is what is important for me, is that we need to see how many poles the alternator has. And in my case, for the Yamaha alternators, normally that number is 18 poles, which means then that the speed ratio should be 9 for my engine. If you are installing it for your engine, you need to really figure out how many magnetic poles your alternator has, and then you need to set that setting accordingly. Regarding my own system, and as you can see from the picture, I have two different electrical systems. One for the starter battery, and that battery is used only for providing electricity for the engine, and subsequently for the gauge that is connected to the engine. And then I have a house battery which is used for pretty much everything else, meaning that it can be powering my Lowrance fish finder, it can be powering an electric anchor, and everything else that is on the boat. In this instance, I am introducing the analog to digital converter, the CX5003, and that device is powered by the house battery. And as we can see in here now in the graph, the converter is also connected to the green cable of the Yamaha outboard gauge and for the RPM signal, and then to the pink cable for the trim tilt signal. And then also there will be an installation for the fuel gauge with a blue cable directly connected to the CX5003. In that case, as you can see from here, there are devices that are connected to both batteries, but in that particular case we might have a conflict where the ground from the CX5003 comes from the house battery, but then the certain signals are coming from the Yamaha outboard motor. So in that case, what we need to do is we need to create one system, and we need to do that by connecting the two negative poles of the batteries together. And what we are doing with that is that we are creating one common ground. The additional bonus that we can get from creating that system with a common ground is that by purchasing a Victron Energy Smart DC to DC charger, I can introduce that to the system, and what I will be achieving then is that I will manage to charge the lithium ion phosphate battery directly from connecting it to the other battery. So when the Yamaha outboard motor is working, the alternator is charging the starter battery, and in turn then the starter battery is charging the lithium ion phosphate battery. This is something that we will be then covering in a different episode in the future once I have purchased that DC to DC charger. Let me show you what I have done so far. So this is the power cable for the NMEA 2K network, and it ends up in this T connection where basically the power is coming through here, and I have now put the one terminal resistor on this side, and then this cable, which is a 2-meter cable, goes through all the way here, and it ends up in the 6-port, and that cable then comes here. The other terminal connector ends up here, and now this cable goes to the Lowrance device, and you can see in here that the device is recognized. The other cable has been now temporarily connected to the CX5003 device, and as you can see, I have connected the ground and the positive to the battery connection from the outboard motor. And as you can see in here, it is recognized as Mars Plus, and it has two sides, the port and starboard. And as you can see here, we have the port and the starboard. So everything is recognized just fine. Now, what I want to do next is, since there are some cables that are going to the gauge back here, not sure how much it is visible, and I want then to connect the tilt trim and the tach RPM and see, first of all, are they recognized to the Lowrance device, and are they working, and also are they delivering correct values. So that is what I will be doing next. My testing continues, and there is something that I want to show you, how you can test that the analog to digital converter works. I have created a very simple layout in here on the Lowrance device, where I'm having the fuel level, the tachometer, and then the trim. And what I have done now in here is I have connected the trim. I have actually grounded it. And what that makes then, it's pretty much a resistance of 0 ohms. In turn, what that causes is the actual network to recognize that there is info. So as you can see in here, now it is recognizing that there is a trim, and if I get the data sources, you can actually see that it's engine, CNTR, trim global, and then we have the Mars Plus port. So we know that this works. I actually, while I was testing, I played around with the fuel tank as well, although I do not have the sensor yet. However, if I come in here, you can see that the info, because I also grounded it, that there is the fuel tank information. And you can see from the data sources in here again that it is the Mars Plus port. Invalid because, if you can see right now, it is not connected anywhere. It is obvious that it is actually working. What I need to do now is figure out a way to connect the cables from down here to the device in here and try it out with the real readings from the engine. What I have done is that I managed to splice that cable, and then I added an extra one and then connected it to the tilt trim. And as you can see, immediately when I actually connected it, it recognizes the trim, so it is low now, and I'm starting to raise the engine now. And down. Up. As you can see, it works. It's not perfect, and in all honesty, I don't really care about this. I would think that for me, the most important thing that I would need to cover is the tachometer and the fuel level. The trim, it's not that important to me because it hasn't really been working perfectly either. And in any case, I can follow it up from here. As you can see, it is much more responsive, much better, so I'm okay following it from here. I don't really care. I believe I'm now ready, and what I want to do is show you what I have done. I have cable managed, I have installed everything to their permanent places, and I have also double checked that everything works. So before I start showing you what I have done, please make sure to like this video and subscribe to this channel. The amount of people that are watching my videos and are not subscribed is quite high. And trust me, I have spent a lot of time, energy and money to create this video. So the least you could do is show some appreciation back and subscribe to this channel. It is free for you, but it means the world to me. Let's now continue and see what is the final installation of my NMEA 2000 network. And to begin with, I have cable managed everything in here. So this is the cable that goes through here that gives electricity to the network. The cable then continues here. And what we see then in here is the CX5003. This is the best place that I could come up for the installation, and I have to say that I'm quite happy with it because it is really nicely hidden in plain sight, and it offers me then kind of interoperability that I can add more devices really easily without really needing to take things apart. Then as I was showing you, the cable then ends up down here, and as you can see, that green cable comes from here and it gets connected to the green cable that you can see in here. And I didn't need to splice any cables. It was already having a place that you could connect a cable, so I haven't really done anything about this. Then the cable continues, and I have put the 6-port for the network in here screwed. So as you can see, this is nicely hidden, but at the same time, again, I can add more cables and more devices. So then this top cable that you see is then connected to the CX5003. And from there on, the other cable from here is connected directly to my Lowrance device. Now, before I proceed with demonstrating how the network works, one small note in here. As you remember, this CX5003 device, it has those 4 screws. You can unscrew that, and then as you can see now in the picture, there are the switches where you set up then the RPMs that are read directly from the tachometer of the engine, and this is a bit tricky. So before I proceed with the demonstration, allow me to explain to you how I did it and what those switches really mean. This is going to be some heavy mathematics now, so please bear with me. The CX5003 device works on a deep switch ratio reference, and it is on the inverted logic. It has 7 switches and each switch has its own weight. Starting with switch 1, the weight is 1, switch 2 is 2, switch 3 is 4, switch 4 is 8, switch 5 is 16, switch 6 is 32, and switch 7 is 64. Now these values are only calculated when the deep switch is set to the position off. If it is on, then that calculation is 0 on the weight. The calculation that we are doing for the ratio then means that it is 1, it's always 1, plus the sum of the weights. So if all of the switches are set to on, that means that it is 1 plus all of the zeros is 1. In my case, I have found that ratio 123 was the best reading that I could get. In that instance then, switch 1 is on, switch 2 is off, switch 3 is on, and switches 4 to 7 are also off. So the calculation then is 1 plus 0 for switch 1, plus 2 for switch 2, plus 0 for switch 3, and then plus 8, 16, 32, and 64. That attributes then to 123. Now, if we look at it from reading the manual for the CX5003 device, it was recommending that the correct ratio for my engine was 9, because I have 18 magnetic poles on the alternator, and then we divide that number by 2. However, when I plugged it in, ratio 9 was giving me a reading of about 45 RPMs. And after playing a bit with those switches, I figured that it was towards the higher number of the ratio that I was getting more correct readings, and I finally then narrowed it down that ratio 123 was the correct ratio for me. If you are struggling with the calculation, I would recommend that you set the CX5003 ratio to 1. Find then what the reading is on your device, and then find your correct target RPMs that it should be reading on the NMEA 2000 network. And from there on, take the target RPMs divided by the ratio 1 RPMs, and that should be your target ratio. That obviously is a very simplified logic that I'm offering in here, but it might be a good start. In my case also, what I tried to do is I asked AI, and this is the answer that I got from Grok. And I will leave you read it now for 10 seconds. And then what I will also do is that I will put all of the tables that I have run through AI, so that you don't have to do it, and you can go through and find what the positions are for each of the switches. And in that respect, then you can pause the video at wherever you find necessary and put the switches to the correct position as you see fit. And now that you have understood how the analog to digital converter works for the NMEA 2000 network, let's proceed with the demonstration. Let's turn everything on. This is for the Lowrance device, and then this one is to turn on the network. Once that has been done, I will turn on the Lowrance. And also put the engine to standby. Everything looks good. We are waiting for this then to load. And as you can see, I have created now this dashboard where we have the trim in here, the fuel level, and I have ordered the gauge, but it hasn't arrived yet, so I'll be waiting. Or sorry, I have ordered the sensor, but it hasn't arrived yet, so I'm not going to be showing this today. And then one thing that you need to be aware of is that this one needs to be showing the RPMs. So if you look at here, it is info RPM, and what you need to do then is choose from the engine the RPM. All right, so now that this is done, I will start the engine. And as you can see in here, it shows about 900 in here, or between 800 and 900. And also you can see here. And also to verify then that the RPMs are reported correctly, we have this one. And as you can see, it says 900. I had to turn the engine off because it was quite loud, but as you can see, everything works really well. I'm really happy about it. It was a really fun small project, if you can call it small. Now it offers me expandability. As said, I will be installing soon the fuel gauge, which is the main reason why I did this project, but also then it gives me more opportunities to utilize various sensors around the boat, have a GPS kind of module that can, if I buy then an electric anchor, the Lowrance device can actually drive the engine itself. So these are really small things that can be added in the future, so I'm really happy about those. That's all I have for you for today. I hope you enjoyed the video. I definitely enjoyed making it, so until the next one, bye.